Number 1, it is asking you to list the domain and range of the relation. The domain is the values of x, which are 5, 4, 0, 4, and 5. Now, you don't list the numbers more than once, meaning since there are 2 4s and 2 5s, we only list them once, and we list them from the smallest number to the largest. So the domain is going to be 0, 4, and 5. My range is my y values, and the same rules apply. So -5, 4, -5, 1, and 5. So arranging that from least to greatest and not duplicating any, my range will be -5, 1, 4, and 5. And that is number 1. Number 2, it is asking you to determine whether or not the relation is a function. For that, you look at the values of x. If there is more than one number of x that is the same, then it is not a function. In this case, it is a function because every single x value is different. Okay, so that is number 2. Number 3, it says, given f of x equals 18x plus 11, find f of 3. So you're substituting 3 in for x. So 18 times 3 is 54, plus 11 equals 65. So number 3 equals 65. Number 4, it says, using the slope formula, find the slope of the line through the given points. So the slope formula is y2 minus y1 over x2 minus x1. Write x1 and y1 and x2 and y2 over your pair of points. x1 and y1 and x2 and y2 simply mean x and y are the first and x and y are the second coordinates. So substituting them in, we'll have 9 minus 3 over 7 minus 5, which will be 6 over 2, which reduces to 3. So my slope is going to be 3 for number 4. Number 6 says, write the equation of a line in slope-intercept form. So that is y equals mx plus b. M is 2 over 7, b is 1. So my equation is going to be y equals 2 over 7x plus 1. Number 7, it says, use the slope-intercept form to graph the equation y equals 8x minus 3. So my y-intercept is -3, and my slope is 8, so I go up 8 over 1 from there, connect my points, and there is my line for number 7. Number 8, it says solve the system by elimination. Since I have a pair of variables with the same number but different signs, I can just add them up. X plus x is 2x, y plus -y cancels out to give me 0, and 5 plus -3 is 2. Now I divide both sides by 2 and it gives me 1. So now to find what y is, I substitute in 1 in for x, so 1 plus y equals 5. So for the first equation, subtract 1 on both sides, I get y equaling 4. So my coordinate's going to be 1, 4. My ordered pairs is the solution, so that's 1, 4 for number 11. The next one, we're factoring, so we write down a, b, and c. A is going to be 1, b is 10, c is 21, and a times c is 21. So now I need factors of 21 that add up to 10. So numbers that multiply to 21 that add up to 10 are 7 and 3. So then my answer is going to be x plus 7 times x plus 3. Number 18, it says factor the following expression. So this is a perfect square trinomial because the first and last terms are perfect squares. So I take the square root of the first term, which is 7y to the third, and I take the square root of the last term. So square root of 64 is 8. But then I'll have 7y to the third minus 8 times 7y to the third plus 8 as my answer for number 18. Number 19 says factor out the greatest common factor. So I can divide out a 5 and an x from both of these as my largest common factor. So dividing 10x squared by 5x, I have 2x. Dividing 15x by 5x, I have 3. So my answer for 21 will be 5x times 2x plus 3. Number 22, it says factor the expression. First thing is to make sure there are no GCFs, which in this one there is no GCF for those three numbers. So then I write A, B, and C. A is 20, B is -41, C is 20. A times C is 400, and B is going to be -41. So any numbers that multiply to 400 but add up to negative 41, that would be negative 16 and negative 25. So now what I'm going to do is rewrite my expression with the negative 16 and then x and negative 25 and then x to replace the negative 41. Okay, so then I have this. So then I'm going to put parentheses around the first two terms and the second two terms and factor by grouping. GCF of these two is going to be 4x, so I have 4x times 5x minus 4. The GCF here would be negative 5. If I have a negative in front, take out a negative 5. So 5x minus 4. Since these two are the same as they should be, I will take out them as my GCF. So I'll take out a 5x minus 4. When I take out 5x minus 4 from these two, I'm left with 4x. When I take out a 5x minus 4 from this, I'm left with negative 5. So I have 4x minus 5 times 5x minus 4 as my answer for number 22. Here to solve the equation by finding square roots, so I just add 196 to both sides, then I take the square root, which will be negative 14 and 14 for x, for number 23. Going down to 27, I need to use the quadratic formula. So I need to write down a, b, and c, which is a is 1, b is negative 5, c is negative 11. So substituting that all in for my formula, I will go ahead and simplify it from there. So minusing a negative 5, I'll just have positive 5. Negative 5 squared is 25. Negative 4 times negative 11 is positive 44. So I'm going to have 5 plus or minus the square root of 25 plus 44 all over 2, because 2 times 1 is 2. 25 plus 44 is 69, so I have 5 plus or minus 69, which I can split apart into two answers, which are 5 plus 69 over 2 and 5 minus 69 over 2. And those will be my answers. 28 says find the discriminant. The discriminant is just b squared minus 4ac. So a is 2, b is negative 4, c is 2. So negative 4 squared minus 4 times 2 times 2. Negative 4 squared is 16. Negative 4 times 2 times 2 is minus 16. 16 minus 16 is 0. And 0 for the discriminant means there is only one real solution. Okay, that's 28. 31, it says simplify the following number using the imaginary number I. So let's go through the I rules real quick. So we have radical negative 1 equals I, negative 1 equals I squared, negative I equals I to the third, and 1 equals I to the fourth. So we're going to start by taking out the radical negative 1. So we'll have radical negative 1 times radical 150. So now I need to look for the largest perfect square factor of 150. That's going to be 25. So I'm going to have radical negative 1 times radical 25 times radical 6. Now the square root of 25 is going to be 5. So I have 5 times I, or 5i, radical 6 as my answer for number 31. For number 32, it is asking me to simplify the expression. So I need to distribute here using FOIL or box method. So distributing, I'll have first 2 times 7 is 14. Then I'm going to have 2 times 6i, which is 12i. Then I'm going to have I times 7, which is 7i. Then I times 6i, which is 6i squared. Now I combine my like terms. 12i and 7i is 19i. And I squared, we're told from the rules that I squared equals negative 1. So replace the I squared with negative 1. So that makes 6 negative, so negative 6. So then 14 minus 6 will be 8. So 8 plus 19i will be my answer for number 32.